Hey everybody, this is Mr. Wolf. We're back with another video. Today we are going to be covering some stuff for the state test, some reviews, some stuff you should have seen, some stuff you may have forgot, and that's okay. Today we're looking at graphing lines in the slope-intercept form. So let's just do a quick slope review so you guys remember some stuff about coordinates and using slope in general. So we want to remember that slope is equal to our rise over our run. And what this means is slope is our change on the y-axis over our change on the x-axis. So let's say we had a point here, and then we had a point something like this, and a line going through there. Let's pretend this line's perfectly straight. We could get our slope by saying, well, our rise is 1, 2, 3, 4, and our run is 1, 2, 3, 4, 5. So our slope would be our change on the y over our change on the x. So our y went up 4 and our x went over 5. So our slope is 4/5 in this case. One thing we also want to remember is when we're labeling coordinates, we're labeling points, you want to label them in this order with your x on the left and your y on the right. So if we were to label this point right here, we could say that this is 5, 4 because we go over 5 and up 4. 5 on the x, 4 on the y. We also want to remember just some basic things, that your x-axis is the horizontal one and your y-axis is the vertical one. If you have those confused, that's a vital thing here. So make sure we get those straight. Graphing with slope-intercept form. Let's first review on what slope-intercept form is. Slope-intercept form is your y equals mx plus b. I'm sure you've all heard this at some point or another, where your m is equal to your slope and your b is equal to your y-intercept. So let's think about what these mean. If we had a line like this, and that's not the perfect line, but we'll say the most perfect line, but let's say this point right here is where it crosses the y, and we'll say that there's another point, it's pretty close to that, we'll say it goes there. So we have 2 points on our line, and we want to kind of show this in slope-intercept form. Well, our y-intercept we can label as this point right here, which just so happens to be 0, 1. The y-intercept is the point at which the line crosses the y-axis. So in this case, it's at 0, 1, or it's a y-intercept of 1. Our slope is, once again, our rise over run. So we can see here you go up 1, 2 from this point, and over 1, 2. So our slope here would be 2 over 2, which is just 1. So if we wanted to write an equation for this line, we could say that this line is y equals 1x plus 1, or you could just say y equals x plus 1, because we don't need that 1 there. Let's do something a little different. Let's say that we don't have a line to start. We have an equation to start, and we want to draw the line instead of labeling the equation for that line. Let's say we're given something along the lines of y equals 1/2 x plus 2. Well, the first thing we know is, well, 2 is our y-intercept. So let's label a point here. That's our y-intercept, our 2 there, because that's our b. The 1/2 would be our slope, because that's in the m position. So 1/2 is our slope. And what is slope? It's rise over run. So we would go up 1 to here and over 2 to here and label a point there. And you can do this again, up 1 over 2. And you can go in the opposite direction, backwards 1, or backwards 2 and down 1, or you could say down 1 and backwards 2. Because remember, your rise is top. Then we can connect these points to get a beautiful line. So remember, when you're graphing these, the first thing you want to look for is that y-intercept. That'll get you a starting point. Then you want to look at where you can get another point from this slope. So let's look at a quite similar example, but say that instead of 1/2 plus 2, or 1/2 x plus 2, we could say it's negative 1/2 x plus 2. So the y-intercept doesn't change. We draw our point there, our y-intercept, but it is negative. So the difference here is that your rise is going to be, instead of up, down. So we go down 1 and over 2. And we can do this in the opposite direction by going to the left one, or the left 2 and up 1, or up 1 and to the left 2. So we draw our line this way, and this is our line. So your first point should be your y-intercept, and then you use your slope to go from there. So given a point and the slope, how can we find the y-intercept? We don't even really have to graph anything for this. But let's say we're given a point, or we're given our slope. So our slope, let's just say, is equal to 3. And our point, oh, not just any point. This is not just any point. This is our y-intercept. Let me label it as such. We're getting the y-intercept. So we have our slope of 3, and we have our y-intercept of, let's say, 0, negative 2. And we want to graph this line. Well, not necessarily graph. We could, but we want to get an equation for this line. So we know that y equals mx plus b, where m is our slope and b is our y-intercept. So we already know we have a slope of 3, so y equals 3x plus, and our y-intercept is negative 2. So you could say y equals 3x plus negative 2, or you could write this as y equals 3x minus 2. And then you could graph this if you wish. We'll do this one real quick, but we won't do this for all the examples. You'd start off with your y-intercept is at negative 2, and our slope is 3. So we go up 3, so 1, 2, 3, and we go over 1. Because remember, any whole number is just over 1, and it's rise over run, so we go up 3 over 1. And that point would be here, and our line would look something like that. What if we're given a point in the y-intercept? So we don't have the slope in this case. We're just given a point in the y-intercept. Let me check one thing. Okay, we're given a point in the y-intercept. So let's say we have a point that equals 6, negative 3, something like that. And we have a y-intercept, I will abbreviate as just y-int, of 0, 6. And we want to get something along the lines of y equals mx plus b. So let's think about what we have. We know our y-intercept, our b value in this case, is just 6 because of this right here. So y equals mx plus 6. Now we just need to replace that m with our slope. So let's look in the difference here. We have a point at 0, 6. Maybe it would help to draw a graph. We have a point at 0, 2, 3, 4, 5, 6 up here. And we have another point at 1, 2, 3, 4, 5, 6, negative 3. We have another point down here. How do we get from this point up here to this point down here? So let's just count. It's rise over run. So let's see how far we go down on the x-axis, or on the y-axis. We go down 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're down 9 this way. And we go over 1, 2, 3, 4, 5, 6. So we go down 9 and over 6. So our m is going to equal negative 9 over 6. Don't forget your x plus your 6. But we can reduce this to y equals negative 3 over 2 x plus 6. Now, you don't necessarily have to draw this out. You can think in your head at exactly what the change is between these 2 points. So let's do it that way. Let's erase the graph and think about it this way. We have 2 points. We have 0, 6, and we have 6, negative 3. How do we get from 0 to 6? This is our x value, so this would be our run. You would get from 0 to 6 by saying plus 6. So our run would be 6. And how would we get from 6 to negative 3? Well, if you wanted to get from 6 to 0, it would be minus 6, but there's minus 3 more on top of that, so it's minus 9. And that's how we get that without worrying about drawing a graph. There's one other example I wanted to do here that I think it didn't quite write out. So let's forget about this saying parallel lines for a moment. And let's say we are given a point and the slope. Not the y-intercept, but just the point and a slope. So let's say our slope is 1/2 and our point is 6, 1. So we want something like y equals mx plus b. We know that m is our slope, so we can go ahead and replace that with our 1/2. So we have y equals 1/2 x plus our b. We need to figure out what our b is. So let's think about what we have. We have something at 6, 1, and we really just want to get this 6 to 0. So what kind of change would you have to make to get that to 0? Let's draw the graph. We have a point at 1, 2, 3, 4, 5, 6, 1. So a point here. And we know our slope is 1/2. So if our slope is 1/2, we got to think backwards. So instead of going up 1 and over 2 directly, we go down 1 and over 2 backwards. Down 1 more, so that'd be here, and over 2. Down 1 more and over 2. And that gets us to the y-axis, and you can see here that this is -1, -2, and our x-coordinates obviously 0. So our b in this case would be y equals 1/2 x minus 2, or plus a -2, either way. So in this one, maybe it's best for you to draw out a graph. You can think about it in other ways to think, well, what's the change to get from this point to the y-intercept? Well, you can say, well, we're obviously going to have to go backwards in steps of 1, to the left in steps of 2, and down in steps of 1. So maybe in that case, it's just a little bit too much to think about. So, but this is how I would do it. If we had 6, 1, we could say we're going backwards 1, or backwards 2 and down 1. So we know that if we go backwards 2 and down 1, we'd be at 4, 0. And let's move our work up here. If we went backwards 2 and down 1 from there, so minus 2 to the 4, we'd be at 2, minus 1, -1 would be our next point. We want to subtract 2 from this side, subtract 1 from this side again, and we're left at 0, -2. And that gets us this y-intercept. Either way works, but I believe that maybe drawing out a quick graph would be easier here. I will leave that one up to you guys. Give me just a quick second to erase all this, and we'll keep moving. Okay, so now we want to look at what this page was originally meant for, and erase this up here too. We were going to talk about parallel lines. So parallel lines are lines that never intersect. So if we have lines like this, and we'll say, well, these go on forever in every direction, or in both directions. So eventually, this one will cut through that one. Those will intersect, and that's not what we want. We want two lines that if you extend them forever, they will never intersect. That's going to look something like this. These lines you could extend forever in any direction, and they will not touch. But what would the slope be of a parallel line? If we had a line and we wanted a parallel line to that, what could we say about its slope? So let's say we have a line y equals 3x plus 4, and that's all you're given. You're not given a graph or anything. And I say, hey, give me another line that is going to be parallel to that is never going to intersect that, without drawing a picture, without thinking about it, just give me another line that will never intersect. And this is actually super easy because the one stipulation here is that the slope has to be the same. So there's an example right there of a line that is parallel to the one above it. We can also say y equals 3x minus 64. Any variation that has your 3 in the slope position is going to be parallel in this case. So let's look at a different case. Let's say I give you a line y equals negative 2/3 x plus 4, and I want you to give me a line that's parallel to it. Well, you could say, well, y equals negative 2/3 x plus literally anything. Anything you wanted to put there would work. Because the only stipulation is that if they are to be parallel, they will have the same slope. So let's clear some room and write this down. This is to say that parallel lines will always have the same slope. Always. So if I give you any line in slope-intercept form, say give me one parallel to it, all you'll have to do is write another line that has this slope. You can't say the same line. That is the one stipulation. I guess I shouldn't assume that to be obvious. You can't say the same exact line. Like I couldn't put a 4 here because those would be on top of each other and intersecting at every point. But any stipulation, you could even do 4.1. Any stipulation, any change to that y-intercept in the same slope will give you a parallel line. Let's talk about perpendicular lines. So perpendicular lines are lines that intersect at a 90-degree angle. So something like this. Kind of like our y and x axes. They cross at a 90-degree angle. So if we wanted to draw or to write a line that was perpendicular to another, I could say, well, y equals 3x plus 4, I believe was our example before. Give me something perpendicular to that. Well, in this case, all we have to do is give the opposite reciprocal of the slope. Let me say that again. The opposite reciprocal of the slope. This is the way I like to think about it. Flip it and make it negative. So flip your slope and make it negative. In this case, our slope is 3, so 1/3 x, and we have to make it negative, plus 4. Or plus anything in this case. Let's just change it. Plus 2. And that will be a perpendicular line to the line above. It's the opposite reciprocal. Opposite reciprocal, which just means flip and make negative. So what if we have something like, we'll circle that to block it off. We'll say y equals negative 1/2 plus 2. Give me a line that's perpendicular to that. Well, you could say y equals, we got to flip this over, so 2 over 1, but we'll just say 2. And it's already negative, so we make it negative again, which just cancels out those negatives, because 2 negatives equals a positive. So we flip this, making it just a 2, and it cancels out the negative. So we could say something like this. And one thing I forgot there is to throw those x's in. So don't forget your x's like I just did. That will make your answer completely wrong. So let's review everything we went over. Let's go back a little bit. Slope review. Slope is your rise over run. When you're writing coordinates, make sure your x is on the left, your y is on the right. When we say rise over run, we mean the change in the y-axis over the change in the x-axis. If we want to graph a line, we first want to graph our y-intercept. In this example, it was 2, so we put a point at 0, 2. And then we use our slope to get our other points. It was negative 1/2 here, so we went over 2 and down 1, because that's a negative 1 on top. Or you could say negative 1, down 1, and over 2. Either way would work. Given a point and the slope, how can we find the y-intercept? Well, you just plug those into to your equation. You'd plug in your slope in the y position and your y-intercept in the b position. So given a point in the y-intercept, how can we find the slope? Well, if we have a point in the y-intercept, we can either draw it out and label these 2 points, draw the line, and then count out the slope, or you can just calculate the change. We said in this case, to get from 0 to 6, we have to go over 6, so that's 6 in the run category, which is in the bottom, and we had to go -9 to get from 6 to -3, so that's -9 in the rise. So we'll write this out here just to clarify. So our -9 is our change in the y, which is our rise, and our +6 is our change in the x, which is our run. We then said that parallel lines will always have the same slope. If you can remember that fact, these problems will be very easy as far as parallel lines go. And then lastly, perpendicular lines, the slope will always have to be the opposite reciprocal, which means flip the slope and make it negative. Remember, if the slope was already negative, 2 negatives equals a positive. There's a worksheet with a bunch of practice problems over this stuff. Get as many as you can done. Get them all done. This is really good practice. This will really help you. And guys, if you paid attention in this video and you feel comfortable with everything I'm talking about, the worksheet should not be too difficult. If you need anything, please reach out to me or Mr. Rose. Will be glad to answer any questions you have.